everyone, welcome back. Today we are going to see another new topic, that is electric field. Okay, so first we define this term, that what this electric field is. Okay, it is basically defined as the space around a charge, okay, or assembly of charge. Space around a charge or assembly of charge. Where a test charge, basically, where a test charge experiences force. Okay, force. Why we have taken positive? Because generally the positive charge is taken because the force on positive charge is actually the direction of electric field. Okay, so that's why we have taken the positive charge. Okay, experiences force, then this region will be called as electric field. Okay, okay. uh, Now we'll see a unit of electric field. Okay, unit of electric field. Okay, or uh, unit of electric field is Newton per coulomb. Okay, or another unit, that is volt per meter. Okay, these two units that we are going to use in this chapter. Okay, uh, then dimensional formula for electric field, that will be ml t minus 3 a minus 1. Okay, this is the unit and dimensional formula of electric field. Now we are going to see which I will be using in questions, that intensity of electric field. Okay, intensity of electric field. Okay, intensity of electric field, or you can say that electric field strength as well. Okay, or electric field strength, right? These two terms are the same. Okay, this is defined as uh, the force that is experienced by charge per unit charge. Okay, means force per unit charge. Okay, this is defined as force upon charge. This is what? This is electric field intensity, or you can say electric field strength. Just a second. Okay, force per unit charge. This is electric field strength. Okay, uh, this we are going to use in problems in this chapter. Okay, and you can also see unit, derive this unit from here, Newton per coulomb. Unit of force is Newton, unit of charge is coulomb. So you can also see from here that unit is Newton per coulomb. Okay, now the next thing, this is also, you can say, the relation between electric field and force. Okay, F is equals to Q into E. Okay, this is a relationship between electric force and electric field. Okay, now we'll see that what is electric field due to a point charge. Okay, suppose, let's say here a point charge is kept, and we want to know the electric field intensity due to this point charge at a distance r. Okay, this is distance r, right? That will be actually, you know that suppose a test charge is placed here. Okay, what will the force experienced by this test charge? That will be F is equals to K capital Q into small q over r square. Okay, now what will be the electric field intensity here? This will be what? This will be the force per unit charge. That means force is what? force per unit charge, that will be electric field intensity here. Okay, force will be what? It will be K capital Q small q upon R square divided by small q. Okay, so this q gets cancelled out, and electric field comes out to be K q over R square. That means that electric field intensity due to a charge q at a distance r will be K q over small r square, or a distance square. Okay, here notice that electric field is also a vector quantity, so you must consider the directions. Okay, now the next topic will be that electric field due to continuous charge distribution. Okay, right, electric field due to continuous charge distribution. Okay, suppose I have told in previous videos that there are three types of distribution will be there. The first one is like linear charge distribution, then surface charge distribution, and then volumetric charge distribution. Okay, so first one we see that linear charge distribution. Okay, suppose you have a conductor, okay, having charge q, and you have your linear charge density q lambda is equals to q upon L. Okay, and if someone wants to know that what will be the electric field intensity at a distance r due to an elemental charge dq. Elemental charge means, suppose this is elemental charge dq. What will the electric field intensity at a distance r? Okay, elemental charge means very small charge. Okay, very small. Okay, then what will the electric field intensity? It will be K dq over r square. Okay, this will electric field intensity. Okay, and for due to whole system means, if we are considering electric a unit charge here, very small elemental charge dq. Okay, then what will be the electric field intensity due to this whole system? Okay, at a distance r, let's see here, that will be integration of this. Okay, that means E is equals to K over r square dq. Okay, and if we consider direction, then this will be unit vector r. Okay, this will be the electric field due to whole system. Now if we are considering a linear charge density, then what will be the value of dq? You know, let lambda is equals to q by L, so we are considering an elemental length, okay, dl, having charge dq. So lambda will be what? Dq by dl. So dq will be what? Lambda times dl. We just need to put this value here, and we will get electric field intensity K over r lambda dl vector r, and we'll integrate this. Okay, K over r. This will be the electric field intensity due to linear charge distribution. Okay, now similarly you can derive for linear charge distribution, due to surface charge distribution, you can derive the electric field. What will be it? It will be K over r square sigma times dA, where dA is elemental area, and this is for surface charge distribution. Okay, and for volumetric charge distribution you can derive. Okay, what will be it? It will be K over r square rho times dV. Okay, volumetric charge distribution. Okay, you just need to consider a small elemental area, and you can derive the electric field intensity, right? So this is all about the electric field and electric field due to elemental area, or electric field due to point charge, or due to continuous charge distribution.